This video is on solving by factoring. We're going to be solving these quadratic equations by factoring the problems first. Then we're going to be using the zero product property. We always want to have our quadratics in standard form so we can factor them. So this first problem here, we have 2x squared plus 4x is equal to a positive 6. This is not in standard form because it's not equal to 0, so we need to subtract that 6 to the other side. So we'll keep a positive 2x squared, a positive 4x, but then a subtract 6, and that will now equal to 0. So if we're solving by factoring, we need to factor this. Our first step is always our GCF. So if we're factoring GCF, the smallest number is 2. 4 can be divided by 2, 6 can be divided by 2. Therefore, our GCF is 2. All three terms do not have an x, so our GCF is 2. We need to rewrite this to have our GCF on the outside. So we're going to have 2 parentheses. We're going to divide everything by the 2. So 2x squared divided by 2 is going to be x squared. 4x divided by 2 is going to be a positive 2x. And negative 6 divided by 2 is a negative 3, close parentheses, and it is still equal to 0. Now, we look inside of our parentheses to determine how to factor further. There are 3 terms, so we'll need to use MACAB. Our A value now is the 1, the B value is the positive 2, and the C value is the negative 3. It's important to get your A, B, and C value after you've factored your GCF out. So we'll use our MACAB, our half box. MAC is 1 times negative 3, so that's negative 3. Our AB is our 2. The numbers that will multiply to 3 are 1 and 3. And in order to make this a 2, if we have 3 minus 1, we'll get a positive 2. So we'll have a positive 3 and a negative 1. Now to make sure it max correctly, negative 1 times positive 3 is negative 3. And it's 3 minus 1 gives us a 2. So this is our MACAB. So with MACAB, now we look to see if we need to use the box. We look at our A value. Since A is now 1, we do not need to use the box, so no box. That means we can go straight into our factors. So our GCF was 2, so that's on the outside of our factors. Then we have 2 sets of parentheses equal to 0. Each set has to have that same variable of just x, so we're going to put x in the front of both of these. And then we're going to use our MACAB numbers to fill in the rest of the parentheses. So we have a minus 1, so we put minus 1. Then we have a positive 3, we're going to put positive 3. So we have factored it, now we have to solve it. To solve by factoring, we use the zero product property. We take each expression that has a variable in it and set it equal to 0. So using the factored form here, the 2 is our first expression. The 2 does not have a variable with it, so I don't have to set that equal to 0. So I go to the next expression, which is the parentheses x minus 1. The x minus 1 has a variable, so I must set that equal to 0. So we have the x minus 1 equal to 0. The next expression is the x plus 3. That also has a variable, so I set this equal to 0. X plus 3 equals to 0. We have 2 expressions that are equal to 0, so we need to solve this by, on this first one, we add 1 to both sides. We get x equals to a positive 1. And on the second one, we need to subtract 3 from both sides. We'll have x is equal to a negative 3. Since x is alone in both of these cases, our 2 solutions are x is equal to a positive 1 and x is equal to a negative 3. So again, what this means is these 2 locations are where the quadratic, the parabola, are crossing the x-axis. So the x-intercepts would be at 1, 0 and negative 3, 0. The roots, solutions, x-intercepts, zeros are where the quadratic crosses the x-axis, and this is the 2 locations where this particular quadratic would cross the x-axis. On this next question, again, we need to put it into standard form, so we need to have this equal to 0. We have a positive 16x squared, so our x squared is positive. We'll need to move the 8x to the other side. We'll subtract that 8x. We'll have a positive 16x squared minus an 8x is now equal to 0. Since we want to solve this by factoring, we must find our GCF. Our smallest number is 8. So 16 can be divided by 8, so our GCF will have an 8 in it. Each of these terms, there's only 2 terms this time, each term does have an x in it, and the smallest amount of x's is just one x, so we can factor out an 8x. So our GCF is 8x. We need to factor that 8x out of the quadratic. So 8x will go on the outside of a parentheses. 16x squared divided by 8x will be a 2x. Negative 8x divided by 8x will be a negative 1, close parentheses, because that was the end of the quadratic, equal to 0. Now we need to see if we need to factor further. Inside the parentheses, we only have 2 terms, so we look for a difference of squares. So you look for 3 things. Is the first term a perfect square? Is the second term a perfect square? And is there a subtraction in the middle? So if you say no to any of those 3, you're done. This first term, 2x, is not a perfect square, so that means we're done factoring. We have factored this as far as possible. We do not do MACAB. We do not do difference of squares. We're done factoring, and that's perfectly fine. Now we need to finish solving this. So we take each expression that has a variable in it and set it equal to 0. Our first expression is 8x. This does have a variable with it, so we set this first expression, 8x, equal to 0. The second expression, 2x minus 1, has a variable in it, so we take that expression and set it equal to 0. 2x minus 1 equals to 0. So again, this first expression does have an x with it. This problem over here, the first expression was a 2, did not have a variable, so we didn't have to use that to solve anything. This one, however, does have a variable, so we have to set it equal to 0. So now we must solve for this x value. On this first one, we have 8 times x. We undo multiplication by dividing by 8. So we'll have x is equal to 0 divided by 8 is 0. X is alone, so we have an answer of x equals to 0. On this next one, we have to add 1 to both sides. So we'll have 2x is equal to a positive 1. Then we will divide by 2 on both sides. So we'll end up with x equals a positive 1 over 2. X is alone, so our other answer is x is equal to a positive 1/2. Again, what these two represent are the locations of where the parabola will cross the x-axis, giving us our x-intercepts, our solutions, roots, and zeros. So we have 2 values that will make our quadratic equal to 0. On this next example, we again need to make sure this is in standard form. We have a 3x squared equals a 48. It needs to be equal to 0 to be in standard form. So we have to move this 48 to the other side because we have a positive x squared. We keep our positive 3x squared, but then we subtract the 48, set it equal to 0. Now that's in standard form, we want to factor. Our GCF, our smallest number is 3. 48 can be divided by 3, so our GCF will be a 3. Both of these terms do not have a letter, so that means our GCF is just 3. We need to factor out the 3 from our quadratic. So we have a 3 parentheses. 3x squared divided by 3 is x squared. Negative 48 divided by 3 is negative 16. That was the end of the original, close parentheses, equals to 0. We need to see if it can continue to factor. So if we look inside the parentheses, we have 2 terms. So again, 2 terms, we look for a difference of squares. So is the first one a perfect square? Is the second term a perfect square? And is there a subtraction in there? The first term is a perfect square. the second term is a perfect square, and there is a subtraction in between them. So this is, in fact, a difference of squares. To factor a difference of squares, we bring our GCF down. We have two sets of parentheses equal to 0. To factor this difference of squares, we take the square root of x squared, which is just x, and we put that in the front of both parenthesis sets. We take the square root of the second term of 16, so that's 4. We put a 4 in the back of both parenthesis sets. And because it's a difference of perfect squares, we're going to have different signs. So one of these is going to be positive, one of these is going to be negative. So I'm going to put a plus sign in the first one and a minus sign in the second one. Now that we have factored the difference of squares inside of our parentheses, we no longer have a quadratic quadratic term. Therefore, we have factored this completely. Now we need to solve this. Any expression that has a variable, we set it equal to 0. The first expression of 3 does not have a variable, so we go to the next one. The next expression of x plus 4 has a variable, so we take that and set it equal to 0. X plus 4 equals to 0. The last expression, x minus 4, has a variable. We set it equal to 0. X minus 4 equals to 0. Those are all of the expressions that have variables, so now we solve for the value of x. On this first one, we subtract 4 from both sides. We have x equals negative 4. The next one, we have to add 4 to both sides. So we'll end up with x is equal to a positive 4. Now, since x is alone in both of those cases, we can say that our answer is x equals negative 4 and x equals positive 4. So the quadratic, the original quadratic, the standard form quadratic, would be crossing the x-axis at negative 4 and positive 4. So our two solutions, negative 4 and positive 4, tell us that our x-intercepts are at negative 4, 0 and positive 4, 0. This last example looks like it's already in factored form, but it's not. If this was equal to 0, it would be in factored form. But because it's not equal to 0, we have to put it back into standard form, and then we have to factor it. We want to go ahead and focus on this left-hand side to get our into standard form as much as possible before we do anything with the 49. So with this first part, I am going to take my x plus 2 squared, and the squared part means we write it out twice. So we really have x plus 2 times x plus 2 is equal to 49. So again, we cannot just say this is equal to 49, that's equal to 49. That's not what we're doing. We have to make sure it's equal to 0 before we can do any solving. So for this, I'm going to ignore the 49 until I need it. So I need to put this into standard form by distributing. So we'll take the x times x will give us x squared. Also the x times positive 2, which will give us a positive 2x. But then I have to take this positive 2 and multiply it to everything as well. So positive 2 times x gives us a positive 2x, and a positive 2 times positive 2 gives us a positive 4. I'm going to keep that equals to 49. Now I combine like terms on the left-hand side, so I'll be able to get x squared plus 4x plus 4 is equal to 49. So we're almost done. We just need to get this back to equal to 0. So this is close to standard form. We have no more parentheses. We need to subtract the 49 to the other side. So in standard form, this problem will be written as x squared plus 4x minus 44 minus 49 is negative 45. And that will be equal to 0. Now that this is in standard form, we can factor it because it's equal to 0. So we're no longer looking at this original, we're no longer looking at the blue. This part right here is now our standard form. We need to factor this one. So GCF. In this problem, this quadratic, our smallest number is 1, so our GCF must be a 1. Each term does not have an x, so our GCF is just 1. So we have to go to our MAC app. Our A value is 1 from our standard form. Our B value is 4, and our C value is negative 45. Our half box for MACAB is MAC multiply A and C, so 1 times negative 45 is negative 45. And our AB is just our B value, which is 4. List out what multiplies to 45, which is 1 and 45. 2 does not work. 3 times 15. 4 does not work. 5 times 9. 6 does not work. 7 does not work. 8 does not work. And 9 is just repeated. Again, I don't use anything with the signs until I figure out how to get my 4. 1 and 45 cannot give us a 4, so I'm going to cross that out. 3 and 15 will not be able to give us a 4. The smallest it'll get us to is 12, so we know that this one's gone. 5 and 9, we can get a 4 from that if we have a negative 5 and a positive 9. So 9 minus 5 gives us a 4. And now we look at our signs. Negative 5 times a positive 9 gives us a negative 45. 9 minus 5 gives us a positive 4. So these are the correct values to MACAB. So with MACAB, we need to determine if we need to use the next box. So we look at our A value. Since A is equal to 1, we do not use the box, so no box. We only use the box, the next box, if A is not 1. What that means is we can go straight to our factors. Our GCF is 1, so we're going to have 1 outside, we don't have to write it, and 2 sets of parentheses equal to 0, because we're going from the standard form problem. Because we don't have to use the box, the front of both sets of parentheses is just an x, and then we use our MACAB numbers. So minus 5 goes into our one set of parentheses, and then plus 9 goes into another set of parentheses. We have factored it, so now we must solve it. Each expression that has a variable, we set equal to 0. Our first expression is x minus 5, has a variable, so x minus 5 is equal to 0. The next expression, x plus 9, has a variable, set it equal to 0. X plus 9 equals to 0. Now we continue solving for the variable of x. So we add 5 to both sides. We'll get x equals to a positive 5. On the next one, we'll need to subtract the 9 from both sides. We'll have x equals negative 9. X is alone in both of these cases, so our solutions are x equals 5 and x equals negative 9. So again, what this means is that our quadratic, once we got into standard form, they would cross the x-axis at 5, 0 and negative 9, 0, because this gives us our solutions, which is x equals 5 and x equals negative 9. It gives us our x-intercepts, which would be 5, 0 and negative 9, 0. It gives us our roots and our zeros. So we have solved this by factoring, by taking this problem and getting it into standard form first, and then factoring the problem so we can use the zero product property.